Good day, bachcho. I am Rakesh Chauvin from Sunbeam Sun City. My dear, you must be knowing while doing the laws of physics in nature, there are two laws still remain behind. One is the law of conservation of energy, and other is the law of equivalence of mass and energy. In between these two laws, there is one more law, that is law of conservation of mass. Now, my dear, let's start with the law of conservation of energy. My dear, there is, when you are writing this law, let me tell you, this law is, everybody know that the statement of law is energy can neither be created nor destroyed. Right? Everybody know about this statement. Energy can neither be created nor destroyed. It can be transferred from one form to another form of energy. My dear, this statement is very important. Transferred from one form to another form. Now you must be knowing heat energy get transferred to sound, from that to light, and all. The energy is get transferred. Am I clear? And in that way the energy get conserved. This is what the people think about. If something is changed from one form to another form, initial amount and the final amount will remain same. Let us see how it is happening, my dear. Do you think it is easy like this, that what we are talking about? Now, my dear, I am giving you an example. Try to understand this example. So, I have given this example to you, my dear. And what is that example? For example, there is a stone. This is a stone. And this stone is falling from top. This is top. At top, what will be there? Sir, stone possess potential energy. And this is called initial potential energy because it is in the beginning. The stone possesses the potential energy, and that energy is called initial potential energy at the top. Now, my dear, assume this initial potential energy which I said, it is possessed at the top. Let's assume that there is no external force acting. No external force acting. Try to understand. This is the condition I have given. That there is no external force acting on this stone. Okay, right. And here is a ground. I am writing here ground. G-R-O-U-N-D, ground. Now, my dear, this stone, when it will hit the ground, try to understand, that's what NCERT has written. When it hit the ground, then definitely there will be a force act on it. ग्राउंड को अगर हिट कर दिया तो ग्राउंड ने तो उस पर फोर्स लगा दिया. तो मेरा कंडीशन क्या है, एनसीईआरटी कंडीशन क्या दिया है कि अभी कोई एक्सटर्नल फोर्स ये स्टोन पे नहीं लगेगा. एंड देयरफॉर माय डियर, इन दैट सिचुएशन व्हाट विल हैपन? I have to take care. What care I have to take, my dear? What care I have to take? Sir, if I will write the word it hit the ground, that ground will exert the force. But I said there is no external force. So what is meaning? Here is the ground, and then here the ball reach, and I will say before hitting ground. Before hitting ground. Why I have said before hitting ground? Because as soon as it hit the ground, there will be external force act on it. But my dear, what the first example given by NCERT, that the initial potential energy possessed by the stone at the top is converted into, here at this point, is converted into kinetic energy before it hit the ground. So what will happen here? The entire initial energy is converted into kinetic energy. Am I clear? And we can say the energy is conserved. That is, here in this example, the initial potential energy, I have written PE, potential energy at top is converted into kinetic energy KE, right, before it hits the ground. The initial potential energy at top is converted into kinetic energy before it hits the ground in the absence of external force. So my dear, here and thus total energy is conserved. So here the total energy is conserved. कब हुआ है? When no external force is taken into account. And the energy is conserved. And here this energy is called total mechanical energy is conserved. So my dear, one example I have given, that if there is a stone and if there is no air offering any resistance on the stone, मान लो air ने कोई external force नहीं लगाया तो वो stone directly आएगा. This is called free fall. Free falling of stone. When I say free falling of stone, it means there is no external force will act on it. And in that case, the kinetic and the potential energy of the top is converted into the kinetic energy. Or you can say, sir, जैसे जैसे body नीचे आएगा, the potential energy is decreasing and its kinetic energy is increasing. I repeat, just as a stone is coming down, the potential energy of stone decreases and kinetic energy increases. But my dear, I am in this topic, the stone is not hitting the ground. Take care. If it hit the ground, then the force will be act. And what will happen? Suppose if this I am doing. Suppose it hit the ground. Then what will happen? This will again rises to this height. Then again the kinetic energy will change into potential energy. It will keep on doing. So here, please take care. Before hitting the ground means there is no external force acting. Such situation is called free falling. Free falling. तो फ्री फॉलिंग जब केस लिया है मेरे बच्चे, दो केस लिया है. सी ट्राई टू अंडरस्टैंड फॉर शोइंग द कंजर्वेशन. क्योंकि साइंस ने बोला इट डजंट मीन कि कंजर्वेशन विल टेक प्लेस ओनली इन फ्री फॉलिंग. साइंस हैज शोन द अदर वे ऑल्सो, where the external force is acting on the body and the energy is still conserved. So please my dear, I am giving you a video where I am showing you a conservation of energy where no external force is acting on the body. It means the body have free fall, right? Free fall का मतलब ही होता है कि once it drop from top, once it release from top, when it start coming from top, there will be no other force, no air resistance, no ground force will act on it. And therefore your NCERT precisely written the law of conservation of energy in two method, two case. One, the free fall case where no external force acting. In there also the initial potential energy which is possessed by a stone at the top is converted into the kinetic energy before hitting the ground. And here in this case, what will happen? The potential energy will go on decreasing as it coming down, and it's converted, and it becoming its kinetic energy, which get convert, the form get convert from potential to kinetic. Am I clear? And entire energy before and after remain constant. So this is one topic which I have done for law of conservation by free fall case. Please take care, there are two cases. By free fall case where no external force act on it. Body directly नीचे आ रहा है from top to bottom, but bottom also the ground does not hit it, because if ground hit it, it apply the external force, whereas question says no, there is no external force. Am I clear? So please my dear, take care of this part, that your law of conservation in your topic has been done in two way. One way, जहाँ पे body is having free fall. What is the meaning of free fall? That sir, there is no external force, no air resistance, no force by the ground will be act, and still the body's potential energy is equivalent. As soon as it coming down, it will be equal to the kinetic energy, and the total energy remain constant. Now I'll show you the another case, my dear, where the external force act on it, on the body, and the energy still conserve. Right? I'll repeat. I'll show you the another case where the external force will act on a body. External force will act on the body, and still the energy is conserved. Right? So please, I'm giving you 2 minutes. If you wish to write anything from this, please write it down. This part you no need to write. This part don't write. So if anything you wish to write, please write it down. So my dear, now let's begin. As I said that in this part is the case where I have conserved the energy by saying no external force acting. Matlab this is applicable for you can say conservative forces. For conservative forces. Conservative forces matlab force on the body is constant. मतलब एक बार जो force लग गया, that is remain constant. Further there will be no external force act. And therefore my dear, when I say no external force acting, other way around you can say, or for conservative forces we have proved this. Am I clear? So please take care, my dear. I am repeating again and again, and the reason behind it, why I am saying again and again, the reason behind it, that when I say for conservative forces, then it means that the force remain constant. And when I say the force remain constant, this means that it is conserved. Force is conserved, and energy is also conserved. Now take care of the another case where for non-conservative forces, what is the meaning of non-conservative? Where the same example, take the same example. So here is the another way, and this will give us the law of conservation of energy. But my dear, we call that as general law of conservation of energy. General. It is applicable to the entire universe, because in the universe there is a number of external forces are keep acting. Please, my dear, take care of this situation. The first was the condition to prove the conservation of energy. But in the second case, my dear, when I said for non-conservative forces, matlab it is applicable to entire universe. Because in the entire universe, there is a number of external forces are acting. And believe me, if the number of external forces are acting, that forces are not balanced. They are not constant. It keeps changing, na? Right? And in that case also, the energy is conserved. Please take care, my dear. That's what I am trying to tell you all, that conservation of energy is taught in your topic two way. एक जहां पे फोर्स कांस्टेंट है, कोई फोर्स नहीं लगेगा, स्टोन ऊपर से गिरा नीचे आया, हिट नहीं करना चाहिए ग्राउंड को, बिकॉज ग्राउंड को हिट करेगा तो एक्सटर्नल फोर्स लग जाएगा, बट नीचे आने तक थोड़ा सा डिस्टेंस बाकी था टच करने में, उसका पोटेंशियल जो टॉप पे था उतना उसका काइनेटिक बिफोर हिट द ग्राउंड होगा और एनर्जी कंजर्व हो गया. जितना पोटेंशियल था इनिशियल पोटेंशियल टॉप पे, उतना काइनेटिक एनर्जी नीचे डाउन पे था बिफोर हिटिंग द ग्राउंड, जहां पे फोर्सेस नहीं लिया, एक्सटर्नल फोर्स नहीं एक्ट हो रहा है, कोई एयर का रेजिस्टेंस नहीं लगा, कोई स्टोन पे कोई एक्सटर्नल फोर्स नहीं लगा सराउंडिंग के थ्रू. बट माय डियर, हियर नाउ स्टिल आई विल शो द कंजर्वेशन ऑफ एनर्जी बाय acting by account of external forces acting and energy is conserved. Now look at this same example. For example, my dear, there is a stone. This is a stone. And this stone is falling. Here is the potential energy. I am writing potential energy at top. Right. And let the stone is coming down like this. You can see in the example. And here is a ground. Let it hits the ground. It hits ground and comes to rest after some time. Try to understand. Right? And here is the potential energy at the top. And now, my dear, let air resistance is acting. That is presence of external force. So air resistance is acting in presence of, you can say, or presence of external force, and let it come to the ground. External force is that it hit the ground. Ground also exert the force. No issues. Now what will happen here? Sir, the mechanical energy, the total mechanical energy is not conserved. Okay. The total mechanical energy is something else, na? Because here the answer will be, total energy is equal to kinetic energy plus potential energy plus energy transferred, transformed from one form to another form. Plus energy transferred from one form to another form. Or you can say in the other way around also. This is a beautiful one. You can say the other way around also, my dear. You can say other way around also, that come to rest, and after some time it will come to rest. Okay, fine. But here I am sure that my total energy, my mechanical energy is not conserved, because it will something else, initial and final. But my dear, मन ये सोचो कि sir, natural, the general law of conservation of energy. What is general law of conservation of energy? Sir, here the mechanical energy of this stone is not conserved. Okay, fine. But my dear, still the total energy is conserved. Why? Because some of the energy is get transferred from one form to another form. Say the energy as soon as it hit the ground, ठीक है, kinetic energy, पूरा potential is not converted into kinetic. Agreed. But that some potential energy which is converted into kinetic. For example, यहाँ पे potential energy था, यहाँ पे ये kinetic energy हुआ. Okay, मैंने मान लिया कि जैसे इसने ground hit किया, मैंने ये भी assume किया कि in between there is a air resistance acting on it. तो जैसे ही एयर रेजिस्टेंस एक्ट किया, द पोटेंशियल एनर्जी और विच इज कमिंग डाउन, विद द पोटेंशियल एनर्जी इट इज कमिंग डाउन, दैट विल लिटिल चेंज. But my dear, that energy is converted into another form. I hope you are getting me. So I do agree कि हो सकता है कि this potential energy is not totally converted into the entirely into kinetic energy, but that potential energy over here is nothing but the sum of kinetic energy plus the energy lost in the surrounding. But my dear, you are not calculating the energy lost in the surrounding. Why? But if you add that also, the total energy remain constant. So my dear, this is called as a general law of conservation of energy. Please take care. General law of conservation of energy. So general law of conservation of energy is for non-conservative forces. तो science क्या बोलता है? What science says? Even the force is non-conserved. Even the force is acting. External force is acting. We do agree कि उसका मैकेनिकल एनर्जी इज नॉट कंजर्व बिकॉज द एक्सटर्नल फोर्स एक्ट ना माय डियर. अब फॉर एग्जांपल ये पेन गिर रहा था, इसके पास कुछ एनर्जी थी, फोर्स इस पे एक्ट हुआ, तो ऑफकोर्स जो मैकेनिकल एनर्जी था वो चेंज होगा क्योंकि फोर्स एक्ट हुआ. So I do agree कि the mechanical energy is not conserved, but after acting the force, वो जो energy possess कर रहा था उसका form change हुआ. I do agree the entire potential is not converted into kinetic, but the potential is suppose 5 joule, right? So it will be, what will be the equation? In that case the equation will be potential energy is equal to kinetic energy plus energy but plus some other form of energy, some other form of energy. So my dear, please take care. We have the two concepts for conservation. One is with conserved forces where the force is not acting, जहाँ पे पूरा potential is converted into kinetic. There is no other form will be come in between. But another where the external force is acting. In that case, my dear, I do agree the stone possesses some potential energy, say 5 joule. That 5 joule, the kinetic energy is not entirely 5. Say it is 3 joule. The 2 joule will be of energy in some other form. Say sound, say light, say heat. So that again, here I am writing, it is 5 joule. I write this one. So here I will get potential energy is equal to kinetic energy plus potential energy of what? Stone is equal to kinetic energy of stone plus some other form of energy, or you can say, बहुत easy topic I am writing here. You can write this also, my dear, that the total energy of the stone, is equal to, come on, or the total energy, you can say, total energy is equal to energy of stone plus energy of surrounding. So this formula is we are getting when we are taking the concept of external force acting on a body. So my dear, take care when you talk about law of conservation. In your topic, the law of conservation being done in 2 ways. The one where the force is constant, जहाँ पे पूरा potential is converted into kinetic, no other forms, but still mechanical energy is conserved, total energy is conserved. And second, if there is a external force act on a stone, then in that case, my dear, the potential energy which is stopped, right, is say it's not complete converted into kinetic energy of that stone, but the rest all energy, rest of the amount of that potential energy is converted into some other form, say heat, say light, say sound, and still when you add total energy it remains constant, and that is called general law of conservation of energy, which is applicable in entire universe. And my dear, this is what is the NCERT has given for the law of thermodynamics also. In a law of thermodynamics we say, when we say dq is equal to du plus dw, what is the meaning of this? The heat which is given to the system is used in two ways. That is, it increasing the internal energy and work done. हम खाना खाते हैं, हमको हीट मिलता है. जब हमको हीट मिला तो वो खाना जो मैंने खाया था, जो मैंने कैलोरी लिया था, वो कैलोरी में थोड़ा सा एनर्जी मेरे इंटरनल एनर्जी को यूज किया, थोड़ा ने वर्क कर दिया, लेकिन सम ऑफ द एनर्जी इज वेस्टेड और लॉस्ट इन द सराउंडिंग ऑल्सो. So if I add this energy and the loss of energy in surrounding, so my dear, addition of this three will remain dq. That is, energy is conserved. So whenever you say the concept of my dear एक्सटर्नल फोर्स, जब भी हम एक्सटर्नल फोर्स का कंसेप्ट लेते हैं तो ये मानते हैं कि पूरा का पूरा पोटेंशियल इज नॉट कन्वर्टेड इनटू काइनेटिक. आई डू एग्री, बट दैट अमाउंट ऑफ पोटेंशियल, दैट अमाउंट ऑफ टोटल एनर्जी इज नो डाउट नॉट इक्वल टू काइनेटिक प्लस पोटेंशियल एग्जैक्टली. इट इज ऑल्सो इक्वल टू सम ऑफ एनर्जी विच इज लॉस्ट इन सराउंडिंग, जिसको हम शायद ऐड नहीं करते हैं, और हम बोलते हैं कि जो इनिशियल एनर्जी है और जो फाइनल एनर्जी है, इनिशियल थोड़ा ज़्यादा होगा, फाइनल कम हो जाएगा, बिकॉज सम ऑफ द एनर्जी लॉस्ट इन द सराउंडिंग. But my dear, if you take that also in account, the lost energy of surrounding, if you add that also, you will find again the total energy remain constant. Thank you, bachcho. Please, you write all this, and then I will take the law of equivalence of mass and energy.
અમે ઘરમાં પુલિસ જોડે આગળ